AOPS number 38.19. Convert each of the following to a base 10 numeral. So we're just going to do A, D, and G. So A, 76 in base 8 is equal to 7 times 8 to the power of 1 plus 6 times 8 to the power of 0, which is equal to 56 plus 6, which is 62 in base 10. D is 311 in base 9. That's equal to 3 times 9 to the power of 2 plus 1 times 9 to the power of 1 plus 1 times 9 to the power of 0, which is equal to 243 plus 9 plus 1, which is 253. And G is 3155 in base 6. So that's equal to 3 times 6 to the power of 3 times 1 plus 1 times 6 to the power of 2 plus 5 times 6 to the power of 1 plus 5 times 6 to the power of 0, which is equal to 719 in base 10. AOPS number 38.22. Perform the following number base conversions. So we're going to do A, C, and E. So A, convert 211 in base 3 to base 5. So 211 in base 3 is equal to 2 times 3 to the power of 2 plus 1 times 3 to the power of 1 plus 1 times 3 to the power of 0, which is equal to 22 in base 10, which is also equal to 20 plus 2, which is equal to 4 times 5 to the power of 1 plus 2 times 5 to the power of 0, which is equal to 42 in base 5. Now C, convert 4133 in base 5 to base 9. So again, we use the same thing, we expand it, and then we find the sum of the expanded thing in base 10, which is 543, and then we break it into base 9, so that this thing is equal to 6 times 9 to the power of 2 plus 6 times 9 to the power of 1 plus 3 times 9 to the power of 0, which is equal to 663 in base 9. Now E, convert 3166 in base 7 to base 11. So we do the same thing, first expand it, and then we find the 3166 in base 10, which is 1126. Then we break it into base 11, so it's equal to 934 in base 11. AOPS number 38.14. The number 10 factorial when written in the base 12 system ends with exactly how many zeros? So the number of terminal zeros is equal to the number of factors of 12 that divide it. And 12 is equal to 2 to the power of 2 times 3 to the power of 1, which means it has to have 2 factors of 2 and 1 factor of 3. So 10 divided by 2 is 5, 5 divided by 2 is 2.5, 2 divided by 2 is 1, and 10 divided by 3 is 3, 1 over third, and 3 divided by 3 is 1. So there's a total of 8 powers of 2 in 10 factorial and 4 powers of 3 in 10 factorial. And since you need 2 2's and 1 3 for every terminal 0 or factor of 12, that means 12 to the power of 4 is the highest power that divides 10 factorial. So there are 4 terminal zeros.